Shit.
I'm really disappointed in you, Miss Clapp. You come from such good, upstanding people. So how's your dad doing, since I'm talking about him?
Oh, he's fine. He just made the decision to like work from home now.
Oh, so now he's working from home.
Yeah. I mean, he'll still travel a bunch. He has to go to Dallas like every other week.
Yeah, I can tell you, when I was in the Marine Corps, that traveling, it's fun at first.
I thought you were in the Army.
That's the old, whatever. I was in the Coast Guard. It really, that road gets very long.
That's what he said.
And usually after 2 years, I don't care if you're in college or you're in the military or you're just goofing off. After about 2 years, it gets old real quick. So.
Yeah, he covers he's got like 25 states as far as his territory, so he has to travel a lot.
All righty. Well, what we're going to do today is, I started the recording, I think, I'm going to just cover some things, and, I don't know if y'all know it. I don't know what you're taking, but when y'all brought up the other day that y'all were, Miss Nethercutt, she's supposed to be at the Easley campus today. I don't know why let me make sure that she's not Skyping in today, because she texted me and said she was moving to Easley, but I just want to make sure. No, it says offline, so she must be moving today. Okay, I just thought I'd cover some things that I looked up. And again, this is not for those people that invented economics. Okay, these are for the students that maybe kind of are either not taking economics or taking an economics-based class with this class. I'm just going to cover a few things, and I'm going to lead it into 6.4. So just bear with me. If you want to write, fine. If you don't, scribble. That's fine with me. I don't care. Just don't be rude. All right, law of demand. And y'all probably talked about this in some of your economics-based classes. Law of demand versus the law of supply. And please interject if I say something different from the economics teachers, because I'm in the back seat here. I'm not driving. The economics teachers know this more than I do. But I'm taking this from videos that I've looked up and the notes that I've looked up. So y'all let me know if I'm going off kilter. But you're talking usually about dollars versus quantity. Okay? And the demand curve is usually going to be decreasing. It can be linear and it can be nonlinear. All right? If you have a lawnmower, let's say that Mr. Crawford invents a lawnmower that can go 50 miles an hour while cutting grass, but it costs $10,000. Is he going to sell a lot of lawnmowers that cost $10,000? No. Versus a lawnmower that costs around $1,500. Okay? So if you have a high price, then your demand is going to be low. Okay? The high price is up there for $15,000, but you might sell one. Okay? I don't know how much lawnmowers are. I'm just making up numbers. All right? So that's the law of demand. The higher the price, the lower the quantity. And that's from a consumer standpoint or a producer standpoint. Versus the law of supply. And I'll do the law of supply. I'll do it in whatever color is there. Green. And that's your law of supply. Now the law of supply basically says that the quantity of supply will go up as the price goes up. All right? And we talked about elasticity. Remember us talking about elasticity? Elasticity is that region that's around here. I just draw that like a bubble But the intersection of those 2 points, what is that called, some of you economics people? Dang old John Nash, dang old equilibrium.
Dang old equilibrium, baby.
Dang old blonde in the bar, dang old for himself. All right. So, and that's called market equilibrium intersection. Now the region around that's the elasticity. And you can go through and watch some of the videos. If you have a price here, if you got one right there, you're talking about a quantity here and a quantity here, but that also can go over here, and then you got a deficit or a shortage. But if you go up here and do it bass-backwards, you got a surplus. And I'm not going through all that, but up here is a surplus, down here is a shortage. And that's basically where we're heading with all this stuff. But this book can't tell you how to make a sandwich without going through 3 units. All right? So a little bit, I told these guys at the Anderson campus, this is the first class that I've ever had to basically teach myself what the book is trying to teach. Okay? That's how bad this book is. All right? So if y'all just bear with me, I'm trying to cover and keep everybody on the same sheet of music while slowly bringing you into what this book is trying to show you. Okay? So anyway, that's that. And I hope I'm drawing the chart at least better than the book was drawing it the other day. So if we take something like bus tickets. And we have a function for bus tickets that bus tickets sell at 81, or the price of bus tickets, or the people that's going to ride the bus depends on the price of the tickets. And the P is the price. And that price is going to be from $0 to $9. Okay? So if you have a price of $0, then you know that at least 81 people is going to buy at $0. Okay? But find P of 3 and P of 6. So do that right quick. Find P of 3 and P of 6. Real simple. It's algebraic, so everybody in here should be able to do that. Now, the elasticity we talked about basically is elasticity is equal to negative P, this is another rendition, times the derivative of P over D of P. This is just another way of writing the elasticity. Okay? And P of 3, what's 3 squared?
9.
Say again?
9.
9. And 81 minus 9 is what?
72.
70 what?
72.
Okay, so 72 people are going to use the bus at $3 versus $9, which if you raise the price to $9, how many people are going to ride the bus? 0. But what about $6? $6 is 36. What's 81 minus 36?
45.
So 45 people are going to ride the bus at $6. What happened?
Those people.
It decreased.
They cheat. They don't want to ride the bus. No, the price went up. Okay? So that's what you see. There's your P and your Y, or your demand and your price, or price and demand, whichever one you want to call it. But what about the elasticity? Let's see what happens at $3. So let's go ahead and find let's see, what's the derivative of this? 0 minus 2p is negative 2p, so that's the derivative. So we're going to take negative p times 2p, negative 2p, over, what is it, 81 minus p squared? And what's negative p times 2p? 2p squared? All right, so write that down. That's your elasticity formula for this parabola. So plug in those two numbers now. You got 3 and you got 6. Plug them into your elasticity formula and see what you get.
That's the derivative.
Got a question? Spit it out. I mean, mathematical question or something.
Yeah, no, I was just wondering why it said 0 minus 2p, but they answered
I
that.
took the derivative.
Okay, yeah.
You have to take the derivative for up here in the right-hand corner. D prime of p. So, when you plugged in 3, what did you get? P of 3 is equal to 0.25. And what did we learn with elasticity when your number is between 0 and 1? Go back to your notes. What did we learn about elasticity when it's between 0 and 1?
Oops.
That's silent. Okay, I'll let y'all look back at your notes, see if you wrote it down in your notes.
Inelastic.
Inelastic, thank you for the one person that wrote it down. Inelastic, meaning that it's not going to what? Inelastic.
Not going to be affected that much.
It's not going to be affected that much. And we see that you got 72 people, and the top you can have is 81. So with that tells you right there that, okay, 81 is the top for this formula, but 3, there's only 72. That's not that big of a deal. So now, what about 6? When you plug in P of 6, what do you get? What do you get?
1.16.
It's 1.6, isn't it?
Yeah.
1.6, and that means the opposite of inelastic means what?
Elastic.
Elastic, which means it does make a difference. Okay? And that's why you see a big drop of 45. And then, of course, when you get to 9, if you was to plug in 9, what you going to get on the bottom down here?
0.
And you can't have 0, which means what? It blows up. So, but put 8. Let's put 8. At $8, 8 times 2 is what? 64 times 128. So that gives us 128 on top. All right? 8 times 2 is what? 64. 8 times 8 is 64. What's 81 minus 64? 17. And what's 128 divided by 17? It's going to be a big number. It's going to be meaning very elastic, which means very effective. So let's go back and type in 8 over here. What's 81 minus 64? 17. 17 people are going to ride the bus. So I think we can pretty much say that if you raise the price to $8 or $7 or $6, you're going to have a problem. Okay, but 3, let's see about 4. 4, if you plug in 4, let's see, 4 times 2 is what? 16 times 2 is what? 32. Remember 32. 4 down here is what? 16? 81 minus 16 is what? 65. You're going to have a decimal, right? 32 divided by 65 is going to be around 0.5, isn't it? Okay, 0.5. Not much big deal. Not a big deal. Let's plug in 4. 4 times 16. 4 minus 81. 81 minus 16 is, what'd you say it was? 65. Again, you still have a busload of people. Huh? 65. You still have a busload of people. What does a bus hold? 60? Something around there. I don't know. So the whole point is you're going to get to a certain point where that elasticity is going to start taking effect. And you're going to start getting the empty bus. And that's what we're trying to find. And that's what the whole point of that right there is. If it's a decimal, then you're okay. If it's a big ass number that over 1, then you know that it's going to be affected. So as a person is putting out a quantity or putting out a service, the elasticity of your business makes a difference. Because, you know, it's like we talked to before. Some people, the iPhone 27 or whatever the next iPhone's going to be called, you got some idiots that's going to go out there and pay $10,000 for a phone just because it's what? It's the next phone. It's the next iPhone. All right? That doesn't, what you're shooting for is what affects everyone. Okay? And that's where elasticity comes in. I think we talked about elasticity in 6.2 or 6.3. I can't remember. But that's that. I'm just going over a little bit more, just trying to get everybody to where we're talking about the same thing. Consumer surplus. Consumer surplus is basically, again, where we talked about and you're going to see a lot of graphs on this. You got your surplus, your supply going this way. And you got your demand going this way. And this right here is going to be a surplus with the equilibrium being right here. Okay? Now, consumer surplus, and I think this is moving into from 6.3 to 6.4, is equal to the antiderivative, and write this down because this is your calculus, from 0 to x of 1, or x, of the demand function minus the market price. Now this is just another way you're going to see this. dx. All right, somebody tell me what these two things are on the graph. What is that? And what is this?
Demand and supply curve.
They're two what?
Parameters.
They're nonlinear, so what are they? Starts with a C. U, R, V, E, curve. Thank you. One person just walked in, and other people sitting and didn't have a clue what I was talking about. All right. So we're finding the area between two what? Curves. Have we done this before? Yes. So it's another way to find the difference between two curves. Another way you're going to see this, or the antiderivative from 0 to x of the demand function minus the market price times the market quantity. And again, you're going to see many different market quantities. So I guess what I'm trying to show you is you're going to be finding the area between two curves. So let's just do a problem and so you can see how you're going to use your calculus. Because I'm going to tell you, there's a little bit of calculus in this chapter, but there's also a lot of algebra. Okay, because you're going to be finding where these two curves do what? Where they intersect. Exactly. So you're going to be using algebra for that, or your calculator. Okay? Setting them equal to each other or finding the calculator intersection point on your calculator. So it's kind of a mix between the two, because what they're trying to do in this chapter, they're trying to merge the economics with the calculus. Is what they're trying to do. So that's why it's not calculus, calculus, calculus banging you upside the head with calculus like in the previous chapter. This one's got a little bit of graphing, it's got a little bit of calculus, it's got a little bit of algebra, because they're trying to merge the two together. So, a demand function follows. Demand function of P is equal to 100 over x plus $1. Okay, so that's the price, and x means quantity. If the equilibrium price is equal to $20, what is the consumer surplus? All right, the first thing you want to do is you got to find out how many units, because that's your x, right?
Yeah.
So you're going to have to solve for x. So do it. That's the first thing you're going to have to do is use some algebra. So 1. Use algebra to find x, or in one case I called it x of 1. Whichever one you want to call it, I really don't care. So how would you do that? Come on, algebra people. No calculus. How would you do that?
You could put it in the calculator, or you could get rid of the x plus 1 on the bottom by multiplying both sides by it.
Well, you got to set the equation equal to what?
To 20.
There you go. Whoever said that. Okay? Set it equal to 20. Who said that? Because I can't see. These screens are so small. Thank you, Easley. I know it was Mr. Crawford probably telling you behind the scenes.
Exactly what it is.
Yeah, he's watching porn on his laptop.
We talked about that earlier today.
Good. So, plug in 20, multiply both sides by x plus 1. Use your algebra. Of course, if you suck at algebra, that's one of the reasons you probably suck at calculus. So, let's go ahead and put it in. 20 is equal to 100 over x plus 1. That means you know how to do that. 20 times x plus 1 equals 100. 20x plus 20 is equal to 100. X is equal to what?
4.
I got 4. So now we got 4. So let's go over here and say $20 is basically giving us 4 what?
Consumers.
4 units or 4 whatever. Okay? So if you was to graph on your 20 and 4, or 4 and 20, that would be the point where they intersect. Now, they want you to find it using your calculus. Now that you've got your 4, it's going to be from 0 to 4 of the antiderivative. So let's go ahead and do that. Second step, set up your calculus. Set up your calculus. So 2. Set up calculus. And like I said, I believe we're talking 6.3, 6.4 right now. I'm trying to make my way through this book, but it's not very simple. So the consumer surplus is equal to the antiderivative from 0 to 4 of our function 100 over x plus 1. Well, we got to multiply it by the market price times the market unit, or whatever I put on there, the market price times quantity, which would be 4 times what? 20, which is what? I'll just put plus or minus 4 times 20. Yeah. 4 times 20. And then put a dx on the end. Or dx, you put the dx over here with the x, I don't care. All right, I'm going to let y'all do that next couple of minutes. Where are you, Miss Kubu? On a boat out in the middle of the Atlantic or what?
I'm in Charleston, but yeah, I am.
Yeah, that's what I figured. Okay, let's all hate Miss Kubu right now. She's on the boat. Who are you on the boat with? Anybody I know?
My family's down here, but my dad and mom are at the grocery store, so they might be here soon. You can say hey to them.
All right. I don't believe I know your mother. I don't know. Where is she from?
She's from Lugoff.
I'm not sorry, what?
It's right outside of Columbia.
Lupa? Like a sponge?
Lugoff.
Oh, okay. I know where that is. Okay.
Yeah.
Lugoff.
Yeah.
Did you say Lugoff?
Yeah.
Oh, I thought you said loofah or something. Dang on living on a boat. Dang on Gilligan's Island. All right. So let's go ahead and let's do this problem. What am I going to do with the 100?
Pull it out.
I'm going to pull it out. So go ahead and pull it out. Now, they're wanting you, since 20 is, 20 times 4 is 80, you're just going to subtract that 80. You're only taking the antiderivative, and I want to make a note here. Take that dx and put it over here, because you're only taking the derivative of this guy right here. Okay? Because of that, you're not going to take the antiderivative of the 80. Okay? And maybe I didn't show you that on the previous problem, but I mean on the examples, but you're only going to take the antiderivative of this right here. Okay, so that's going to be equal to 100 antiderivative of 1 over x plus 1 dx from 0 to 4 minus 80. And 1 over x plus 1 is the natural log, right?
Yep.
1 over x is natural log. So 100 times the natural log of x plus 1 evaluated at 0 and 4 minus 80. So I'm going to put this in red brackets because you're going to do this first. And then you're going to minus the 80. So go ahead and do the math with the natural log of 4 plus 1 and the natural log of 1. Well, the natural log of 1, I'll do that one for you. The natural log of 1 is 0. I did that one for you in my head. Aren't you impressed?
Oh, yeah.
get a net up on my glass. Drive me crazy.
Oh, we don't.
Oh, yeah, Miss Deborah Lewis. Get her number. You can be set up for there's nothing I can do for your school. Closed 26. I called the registration office. They're like, yeah, you can call our teacher and get in. So now it's just.
All right, tell me what y'all come up with. Well, you are a winner. 80.94. Huh? 80.94 is your answer. And that's your consumer surplus. Now, I'm not going to sit here and explain to you what consumer surplus is. Is there anybody in here that has had the courses that can explain what that number is?
Valbone, you didn't tell me what consumer surplus was.
I'm sorry, what?
Valbone, you didn't tell me that.
Well, I'm sorry about that.
It's a tough life.
I know. All right, so here is another problem that you might see in this section, 6.3 and 6.4. I think it's 6.4 mostly. And I'm going to put the 6.3 and 6.4 homework up, but I didn't want to put it up until I covered today's class. Do we have class Wednesday?
No.
Okay, what about tomorrow? I mean, not y'all, but when is we only out for the 4th, right? Yeah. Okay. All right. So here's two formulas. We've got a supply price at $1.95 minus 5.8 X. And then we've got a demand price at 150 plus 3.2x. So basically you've got two, and these are in millions, okay? The units are in millions. The units of quantity are in millions. And of course the price, I ain't got to tell you what the price is. Price is in dollars, okay? So we've got two lines, and you can set them equal to each other and find out where they cross. So let's do that. And yes, you could do that with your calculator. Do it with your calculator, or do it by hand, or do both. 195 minus 5.8x is equal to 150 plus 3.2x. And the biggest bucket is 3.2x, so we're going to move the smallest bucket. 5.8x. And that's going to give us 195 is equal to 150 plus, what, 9? Somebody help me out.
Yep.
And you're going to get 45 is equal to 9x, so therefore x is equal to 5. So we got an intersection point at 5, comma, and plug it back in to figure out where the y is. So somebody tell me what the y is. I think I did it. 166. Y is equal to 166.
Yeah. Yep.
So we could be talking about, I don't know, dang old, something expensive, houses, 5 houses, whatever the case may be, because you're talking about 166 million. Or $166 for 5 million. There we go. Sorry, that's the wrong way. So that's how you would find the intersection point, and you could use your calculator, and this is a little bit of algebra they brought in. Okay? So this is 100% algebra. Now, what if they give you a useful lifetime? Useful lifetime of a product. And that's when you're going to be using your integration also. This may be a little bit 6.4, 6.5. So write it down as 6.4-6.5. Useful lifetime of a product. In years is given by f of t 0.1, 0.1 e to the negative 0.1 t. And t is between 0 and infinity. For one end of the spectrum, you got Chevy trucks, which might not last 1 year, and then you got Dodge trucks, which last pretty much until you shoot them. Oh, they didn't get a response out of anybody. Why is everybody dead today?
Monday.
Find the probability. Oh my goodness, find the probability. Find the probability. We done jumped into another math now. Will somebody tell me, I wish I had Miss Kubu. Where's Miss Kubu?
Right
She's
here.
on a boat. Okay. Miss Kubu, do you remember in my Math 120, some of the probability we found was area under a what?
Curve.
An area under a curve. So we're going to be finding the area under a curve because that's the probability. So putting probability right here, area under a curve. And it can't go over 1 because probability, is a percentage from 0 to 1 or from 0 to 100%, depending on which application you want to use. Find the probability, the area under a curve, that a randomly selected unit will have a lifetime that a randomly selected, and you can write that out, I'm not writing all that out, randomly selected unit will last 2 years. No more than 2 years, sorry. No more than 2 years. Now, what does that mean? What does no more than 2 years mean? It means from
Within
0
the
to
span
what?
of 2 years, you need a new one.
0 to 2, exactly. So, we've got to find the area under this curve. Now, if you drew this, I don't know if I have it drawn or not. correctly. I think it's going to look something like, I got something like this. So, and this would be the 0.1 up here, 0.1, and this would be 1, 2, 3, 4, 5, 6, 7, 8, to infinity and beyond. So we're trying to find the area right here. Area under a curve. So I want you to do it. Because technically, all of you should be able to do this problem because this is nothing but basic what? I-N-T.
Integration.
Integration, thank you. It only took 3 letters that time.
Oh yeah.
Paying attention. All right, any good movies this weekend?
I saw Hereditary.
How was it?
Not bad, but I mean, I wasn't overly scared.
It seems like to me it's not a scary movie. It's more of
It wasn't that bad. There was some pretty graphic scenes, and it was kind of weird at the end, but.
So does it have any demons or spirits in it, or is it just scary?
Yeah, it's kind of like a spiritual thing.
Yeah, it's real,
about like
it's real
the soul.
spirity.
Yeah.
Oh, okay. Well, then I'll go watch it then.
What do you prefer? What's your go-to? You want to
I
see somebody
love
get
the-
stabbed, or you want to see somebody get possessed?
I love the possessions, paranormal activity, the demons. I like the.
Are you gonna watch The
Conjuring.
Nun when it comes out?
I'm going to see The Nun. I'm going to see it.
Hubert, something's wrong with you, man.
Dude, The Nun looks good.
Why?
I love possession.
But you
Well,
don't
I'm
like
very
The
confident in
Conjuring,
my
right? Is that what you're
spirituality.
saying?
I'm not going to let Van Halen or Five Finger Death Punch or a movie sway my spirituality. I'm very confident in my spirituality.
You like Five Finger Death Punch?
Yep.
Rock on, man. Hell yeah.
That's the only reason I like it is because I lift weights to it.
Oh, yeah. you
Hell
do.
yeah, you do. Drinking that pre-workout now.
Okay,
Yeah,
be
do it.
quiet.
At Planet Fitness.
At Planet Hubie's gym.
I want to go to the gym with Hubert, too.
Piss him off so much. He lifts so much, too.
No, Hubie's gym, nobody can go to it. It's members only.
What gym you go to?
Hubie's gym.
Hubie's gym.
Yep,
Maybe
called
you
that
like hoops or something.
garage.
The garage.
I have to show you my dang old garage. I'm kind of proud of it. Dang old show thing.
I genuinely, with all my heart, want to see it.
Somebody is honestly going to complain about this, but I don't really give a shit.
Oh, he's doing it right now. Hell yes.
I thought we were getting invited over.
Somebody's going to, by the end of the day, my
That's your
apartment
garage?
will fall.
That's his house.
You really didn't talk about math the whole time. No, I didn't. Let's see. Dang old.
Does Nicole live with Andrew?
Jacked out of his mind.
Oh, yeah. He's got his normal page, then he's got his workout page.
Let's see if I got my daggum. Let's see. Where's my pictures at?
Do y'all talk? I mean, is she friends with
Oh, yes.
Hell yes.
Dang old, there's my dang
Look
old.
at that
Somebody
one.
sent me.
I've seen that
There,
one.
there.
I've seen that
Somebody
one.
sent me how to get. I found something I thought you might be interested in for the Red Hornet. Dang old smokestacks. He's being funny. I sent him a thing back. There it is. There's my gym.
Oh yeah, baby.
Damn.
I don't
So
play games. Hitting that punching bag.
dang old 25 by 25. Dang old very small. But it gets the work done. You have to move a lot of stuff. So if you want to do the punching bag and you got to pull it out, you got to move this. But it's all right.
You know what I see right there? I see we getting our cardio in.
Mm-hmm.
I got elliptical and treadmill. I do an hour.
An hour? That's pretty good, man.
30 on both.
Dang.
Heck yeah.
What's CVS Pharmacy doing on the? I'm an insulin dependent.
Dang old Thomas
diabetic.
Maxwell, man. Can't do a thing about
He's
it.
insulin dependent. Are you going to be like that now? He's sensitive.
I don't care.
How do you know Thomas Maxwell?
It says the name.
Oh, you don't know him. You just okay.
No, I know Tom. I know old Tommy.
Yeah, right. I don't believe a word you're saying. All right, so whoever's going to complain, go ahead and complain.
I'm calling your
Alright.
department head now. This is
Yeah, go
ridiculous.
ahead.
Should invite him over.
I wanted to do calculus the entire length of this class period.
Yeah. All right,
We
so
can
here we
calculate
go.
the amount of weight he lifted over his life.
So where are we going? From 0 to infinity, or from 0 to 2, 0.1 e to the negative 0.1 t dt. And when you do that math, and you can do it on your calculator if you want to. Let me get my paper. Where'd my paper go? Here it is. Miss Clapp, what'd you get on the calculator? 0.148? I'm
Yeah.
sorry. 0.181?
Yeah.
Good. 0.181. Now somebody tell me what that is. 18 what? 18.1%. So, if you picked out one of these units, okay, and you found what is the probability that one randomly selected unit will last 0 to 2 years? 18% chance. So that's pretty good. At least it's not 98%. 98 means your product what? Sucks. There you go. All right, now do 2 to 4 years. We're leading up to something here, and Miss Kubush, I'm going to depend on you to get it right because you just came out of my statistics class in a minute. So I'm going to put you on the spot. If you don't get it right, that means you pretty much are failure. On that gum boat, that gum Atlantic Ocean, dang old. Should have went down to dang old Gulf. You dang old Caesar. What's fixing to
Pacific
be?
Ocean.
Keep it here at a marina, so whenever we come down to Charleston, we just stay here.
I like to see what's fixing to bite my leg in half. You know, that's positive in my. Can't see that in Atlantic. Too much yuck.
When I went to Hawaii, it changed everything.
Dang old chomp chomp chomp. 2 to 4 years. B. B. 2 to 4 years. And of course, I'm going to take my handy dandy red marker and I'm going to draw that area right there. So that's going to be 2 to 4 years. And of course, all you got to do is change your calculator to do the antiderivative from 2 to 4. And then 0.1 e to the negative 0.1 t dt. And that's going to approximately be, what'd you come out with?
14.8.
148,
Yeah.
which is equal to 14.8%. All right, now I want you to tell me, and I'm going to put it in this little area over here because it shouldn't take you very long. Miss Kubu should get it right off because she come out of probability. C, what is the probability of more than 4 years? Look at your graph. Look at my graph over there. Miss Kubu's giving everybody a chance. She knows the answer because she came out of my 120 class, but she's giving everybody a chance to get it because she don't want to step on anybody's toes. Right, Miss Kubu?
Sure.
She has no freaking clue.
That was senior year.
Okay. Yeah, that was a whole year ago, wasn't it?
No.
How old are you? How long ago was that?
I'll be a junior in college, so.
Okay, 3 years. Or 2 years, because I don't know, you did so many classes, so you probably got two or three classes out of the way. What does anybody out of 120 can tell me what the word is that I'm looking for?
Convert.
Convert. I heard convert.
Convergent.
No, you're wrong. You're a loser. Live PD.
Hey, shoot your shot. You know, sometimes if you never shoot, you're never gonna land anything.
Where do you get some of this stuff? Why
That's
you got your
modern
hoodie
motivation.
on? Why are you trying to look ghetto?
I'm not. I look dumb more than I look ghetto. It's kind of cold in here, man.
He's trying to fill out the live PD. That's what he's trying to do. You got to get less teeth. Knock all your teeth out.
I come to your class every day and I take notes, but you think I'm taking notes on math. I'm actually taking notes on how well you bullshit everything.
Yeah, exactly.
So I just been trying to
Just
get
remember
good
you're
at doing
recorded.
that.
You got to knock your teeth out, and you got to smoke. You got to smoke 3 packs of Marlboro Reds a day before you can make it to live PD.
Right on.
All right. So what is it?
Smoke
C
and work out at the gym at the same time.
O M P L I.
Get the first letter.
Complimentary?
Not complimentary, but the root word of complimentary.
Compliment.
The compliment. What is the compliment?
I just said that.
Well, I couldn't hear you. I'm sorry. Because your hoodie is in the way.
It's too bright in here. You can't hear.
Yeah, it keeps
Too
your
bright
jaw from
here.
moving. What is the compliment? For those of you that had statistics, what is the complement? It's what makes up the whole. The whole meaning 1 or 100%. So I'm going to take my handy dandy blue marker and I'm going to color in what's left. Now, do I have the black area?
Yes.
Do I have the red area?
Yes.
Then I just have to take those away from 100, and that will give me my answer.
That's what I
100
did. I just didn't know if it was right.
minus, I'm sorry, what'd you say?
I said that's what I did in my calculator. I just didn't know if it was right or not.
Okay. 18.1, I thought you were just trying to help everybody out. 14.8, and somebody tell me what that comes out to be.
67.1.
All right, 67%. So basically, you have told your board of directors that 70% of our products are going to last pretty much 4 years or more. Is that good? Yeah, pretty much. I mean, I think it's not catching the woods on fire, but it's not my pillow standards. My pillow is 100% guaranteed. Anybody got a My Pillow yet? Some of y'all have nowhere to see.
That's seen on TV pillow?
Yeah.
Oh, it was like $30.
Yeah. I think they're like $50 for one.
One of those espionage things. It's really nice book. I have like $200 pillows. There's
I have one pillow and it's $8.
So for example, could an auto manufacturer use this equation to figure out how long their warranty should be on the car?
That's exactly where you would use it. Whoever said that, I'm very, very, very impressed.
Oh.
That is exactly what you would do. So, whoever said that, I'm assuming it was Mr. Crawford whispering in your ear, wasn't it?
Yeah, he's got his headphones in. He's got another man talking on the line too.
Okay, I figured.
Econ teacher.
1-800 get a date.
I got Valbonia's on the phone.
Yeah.
She's helping me out.
He's talking to his boyfriend. Okay. All right.
Come on,
so
boyfriend.
here's the
Get
type
the
of
hell
question
outta
you're
here,
going to
dude.
get. The supply
Hey, you
and
leave my boyfriend
demand
out of this.
D of P is equal to negative 1.002 P squared minus 20.713 P plus 843.675. S of P, that's your demand, this is your supply, is equal to 0.312 P squared plus 8.423 P plus 247.391. And P is greater than or equal to 5. And these are in $100 per sculpture. It says the supply and demand for marble sculptures is shown below. The demand and supply are given by these two formulas. Now, what they want you to do is basically find the intersection point. And I would highly suggest not to do it by hand. Unless you just like the punishment. Now they want you to find several things. The first thing, I'll write down some of them. They're wanting you to find the I'm just going to say the intersection, but you can call it equilibrium. Intersection. But you do that by the calculator. B, they want you to, at equilibrium, they want you to compute consumer expenditure, C, at equilibrium, they want you to compute producer expenditure. Let me get D. D, producer surplus. I'm just going to skip to F. Consumer, we'll call it E. Consumer surplus. And that's enough.
Yeah, proceed.
All right, somebody tell me where the intersection is.
$12.93, 408.43.
Okay, for rounding the purposes, and we're going to talk about that in just a minute, 928, comma, 408,429.
All right.
Now, I'm not being a stickler, but one thing that you'll find out in business, marketing, international trade, do they round everything to the hundredth? Yes or no?
I'm going to guess so since you did it.
Nope.
Okay.
They do not round to the hundredth. In fact, many years ago, at least be at 20 years ago because it happened before I started teaching, there was a guy that worked at the World Bank in New York, and guess what he did for a living? He was a computer programmer. And guess what he did? See, the World Bank carries your money to the 16th decimal point of a penny. Okay? So he just decided, working at the World Bank, that whatever deposits come in, he would shave off the last 6 digits and put it in his own personal what? Savings account. By the time they caught him, he had over $2 million in the bank.
Dang.
2.5 years he was doing it. Well, he wasn't doing it. The computer was doing it. The whole point is they carry, when you get into marketing and you get into business and you get into international business, especially with the international banks, you're carrying it to the 5th, 6th, 7th, 16th decimal place. All right? So for giggles, let's keep this one at 3 decimal points because your answers may come out a little bit different if you round to the hundredth. All right? The equilibrium is going to be the same for B and C. Okay? I came out with 5280, 179. 5280, 179. That's where you take P and you multiply it by Q. So 12.98928 times, in other words, you remember the second part of the problem where we did 80? Y'all remember that? We multiplied the two together, 4 times 20? That's what you're doing. So this right here, just remember in the previous problem, 4 times 20, and we got the 80 in the integration problem, remember? All right, now, produce a surplus. Go ahead and do your integration, just like we did in that 40-20 problem, or that 4 times 20 problem. It's going to go to 12.98. So you're going to set up your integration from 0 to 12.98 of the function. Which function is it going to be?
The top one?
Should be, yes. I'm sorry, the second one, S of P. Should be S of P, your price, your supply. Sorry, I messed up. So that's S of P, dP. They're doing this in sections is what they're doing. And somebody tell me what you got when you did that. I'll tell you it's going to be around $2,700. Or around, $2,700. So tell me what you get when you get it. We're going to leave the E off for right now. I'm just going to finish with this one.
4,126.
What'd you get? For B, you should have around $2,700, a little bit over 2,700. What'd you get, Miss Kubu?
I got. Okay, well, is it for 12.928 or 12.98?
12.928. I'm sorry.
Okay, for that one, I got $4,126.86.
How much did you get?
4126.864.
Mm-hmm.
8 or 9.
Better check it. Because it's supposed to be around 2771, I think.
I got what you got now.
12.928. There we go. It shouldn't, because 12.928. Take the antiderivative of S of P. So that's going to be 3.12 P to the third over 3 plus 8.423 P squared over 2 plus 247.391 P. Is that what y'all got? And that's going to be evaluated at, wait a minute. Oh, shoot. Sorry. What does it say right here? I told you wrong. It's what happens when a man don't read directions. What does that say?
Just greater 5.
5. So this is supposed to be a 5 right here. My bad.
Keep saying the show.
I screwed up. I told you wrong. Should be 5 to 12.98 because the price is going to be greater than 5. $5 or 5 whatever.
Okay, now I get it.
Try that now.
I got 2771.62.
There we go. That's what it's supposed to be. 2771 what?
2771.622.
And that's going to be your producer surplus. Okay? So, this is what you're doing. You're going to be given 2 equations in this section. This come out of 6.4. Okay? You're going to be asked to find the intersection point. Then you're going to ask to take those 2 numbers and multiply them together. Then you're going to be asked to find the producer surplus. And the producer surplus is the antiderivative from your points X, A, and B of the spending formula, and you've got to make sure it doesn't have a parameter on it, which I wrote the parameter down, but I didn't even think about it when I set up the integration. So that was my mistake. And I want to just focus on these things. So, in 6.1 we talked about converge and diverge. Now, what does that have to do with it? Well, actually, you could have used the converge or diverge on this problem right here, right there, from 4 to what? From 4 to infinity. You could have used it there, or you could have done, you just did the complement. All right? So 6.1, I want to make sure you can do infinity. 6.2, what do we talk about in 6.2? Look back in 6.2, what do we talk about? What? Future value and present value. Talking about business. Talking about money. Third, we talked about elasticity. We talked about equilibrium. We talked about that area around the equilibrium where it can be elastic. Okay? And in 6.4, we're talking about what to do after we get to that equilibrium, what to do with it afterwards. And this is what we're doing with it. What do you do with it? Well, you find the consumer, the producer and the consumer. I'm going to talk about, hold on. You talk about the producer surplus, and when we come back after the break, we'll talk about consumer surplus. Okay? Questions so far? Now, somebody look on your outline. I think we're only supposed to go to 6.5 or 6.6. What does the outline say? Somebody look on the outline, that very important paper I told you to look at. Keep in your notebook.
It says
Let me think.
4.
I'm sorry, what?
4.
I see up to 6.4.
We only go to 6.4?
Yeah. It says.
All right. So we just got to finish 6.4 and y'all ready for Unit 2 test. All right. Y'all get out of here and have a good 4th. Anybody want to stay for questions. Tell your daddy I said, hey, Miss Kubu.
Oh, hold on, I'll show you. He's right there. He's talking to somebody. There he is.
Well, tell him I said, hey.
I will.
We'll see you. Bye-bye.
He's right there.